So a quick summary of Akka Streams. There's basically three parts: sources, flows, and sinks. And I'm showing in Scala some definitions in this program where we have one source, one flow, one sink, and we hook them up together. The idea is to build a pipeline that processes data from a source of information through some kind of flow to some kind of destination, a sink. So you do source.via flow to sink, and then you ask it to run. None of these lines of code do anything except until you hit .run. They basically just set up an architecture of a thing that can be run. So when I do source 1 to 100, it says, okay, we're going to create a source that when you run it, it'll count off integers from 1 to 100. And when I say flow.from function, it's going to divide all those integers by 2. And then when I do for each, it's going to print them. Okay? The other lines, the implicit val lines up there, are just sort of some boilerplate that you need in order to make all this work. So that's kind of quickly it for how you set up Akka Streams and use it. This is what I've done with it. On the left in red is the input. So I'm going to take some things from the mouse, from the keyboard, from the window events, and I'm going to put them into these things I call devices. So I take the mouse Y position and turn it into pitches. And I take the mouse X position and use that for the volume. So I can move the mouse around and make volumes and pitches. I have a mouse buttons, can control the portamento. The mouse wheel selects instruments. I have enter and exit window events, which turn the whole thing on or off. And keyboard events, there's two types of those, normal and special, and they do some fun things. All of those things flow into this big blue blocks. And, oh, sorry, there's another piece there, which is pitches and volumes. That's just an amalgamation of those two inputs, pitches and volumes. So all of those things generate a music maker message. So play note, set pitch bend, change instrument, ignore notes, resume notes, play note, those are all music maker messages. And the MergeHub there merges all those things and then broadcasts it back out to other components. So in the green, we have the screen output, and in the music maker is the piece that actually generates the sound. It's using MIDI. It's not particularly fancy. I took some shortcuts here. So that's the basic architecture of the program that I wrote. So you can't see this. I'll show it to you when I get to the Raspberry Pi part. But I'm moving my mouse down. And up. And I can change the wheel button on the mouse here to change the instrument. I've just changed it to instrument 7. And now 13. And 22. Okay. A bunch of MIDI instruments that I can play there. And I can change the volume by moving it left and right. That's the portamento. It's not sliding particularly well. All right, so that's the quick demo. So let's look at all the magic that makes all this happen. Mouse back over here. I'm going to come down there and walk around because I need to. So creating a source with an actor. So at the top there, I'm creating a stream. And it's done with an actor. That's the source.actorref part. And I've given it a buffer of 100 messages. and an overflow strategy of drop new, which says, if that buffer of 100 things fills up, start dropping the new things. Leave the stuff in the buffer there. So messages sent to an actor become elements of the stream. So all I have to do is send something to an actor, and Akka Streams will provide that actor to me. And anything sent to it gets put on the stream. Okay? So this allows me to feed the input by just using an actor, sending the actor messages. As you can see, you need to pay attention to the overflow strategy because there is no back pressure support with this kind of source. I do something here called pre-materialize, which is to get the actor out. Materialization is a part of Akka Streams that allows you to create something when you run the stream. And this pre-materialize says, well, don't wait till you run. You can just do it now, create the materialization. In this case, the materialization is the actor to send the events to. As you can see in the val statement there, we get the event actor and the source. So I give an example of using this. The mouse wheel moved function there is sending a message to the event actor. It's setting a mouse wheel rotated message. It's pulling out of the swing event, which is mouse wheel event, the value for get wheel rotation. This is how I change instrument. Right? You saw me change the instrument. This is where those events come from. And they get sent into the event actor. The exclamation point there, if you're not familiar with Akka, it means send a message to event actor. Okay, so that's how we get data in, by sending it to these actors. But there were mouse events and keyboard events and window events. Now I need to break them apart again by type. And so you can use collect type to essentially filter that stream of events by type of event, not by some function. So the way you do that is with the collect type call on the source. And here at the top, I'm showing mouse wheel rotated. I'm again going after the instrument control. And you pass in that type and the class tag for it. At the bottom, I'm doing the portamento control, which is mouse clicked. Next up is generating elements at a fixed rate. So the mouse controls the pitch and the volume. But mouses are notorious for generating huge numbers of events very quickly, which can be CPU intensive. And so I thought, both for demonstration purposes and to control the amount of CPU used, that what I would do is collect that information at a fixed rate. So here I'm saying source.tick. I'm telling it to send an event at a regular rate. That's what tick does. The event is a unit. It's nothing. It's null, essentially, if you're not a Scala programmer. And that's those two closed parentheses parameters, the last parameter to tick. The other two parameters are how long to wait initially and how long in between each tick. Okay, so I've got a configuration value that I can control, and it's config.sampleRate. In this program, I have that set to 100 times a second. So every millisecond, I'm going out and getting the mouse position. And the way that happens is with this map. So I'm mapping that unit value into a call to mouse info get pointer info. That call gives me where the mouse is. I get the location for it, and I turn that into a mouse relocated event. So this is how I generate the mouse relocated events on a fixed schedule once every millisecond. One of the things you can do, and we've already seen examples of this, is to transform an element in a stream using the map function. This is very much the same as functional programming. It's a map. You get the current value. You can turn it into whatever you want. Here what I'm doing is I'm going after the instrument control with the mouse wheel rotated source. That gives me the mouse wheel rotated events. Mouse wheel rotated source was the result of the collect type. Remember a couple slides back, there was a collect type, and we wanted to collect type of mouse wheel rotated. So I know it's always going to be a mouse wheel rotated event because I'm using that source. I do a little bit of computation to make sure the value's in a range, and multiply it, or make sure it's between 0 and 126. That's a MIDI requirement. And so this just converts it into an integer that I can use with MIDI. You can also transform elements in other ways using flows. So here I've got a few things going on. I'll take a moment to describe it. So it doesn't matter what the data source is in particular here, but it's the instrument value again, the one that I was just showing. So we're going to take that data source and flow it through this function, which declares the instrument parameter that's coming in. And then it's going to call pane data copy to set the instrument value of pane data to instrument. I could have named this a bit better. Okay, so that's basically just setting pane data to the current value. Pane data is just some global variable. Flat map concat is how you change a stream into the result of multiple streams. So what that does is, it's taking the instrument value in, which is an integer, and it's saying, apply this vector, which contains two things, a change instrument of going to two different channels. So the first argument there is the channel to go to, and the second argument is the instrument. So instead of just mapping it to one thing, I'm actually creating a new source that has two elements in it, one for each channel. So I'm changing one instrument change into two events. And that's what flat map concat does. Instead of taking a new value, it takes a source of the new value. That one's a bit tricky. Any questions on that? Okay, you're all expert Scala programmers. That's great. Next up is merge and broadcast. You remember where there's that big blue bubble in the middle where everything was coming in and a few things were going out? This is what does that. So here we're saying source.combine. This is combining multiple sources. In this case, pitches and volumes, on-offs, keys, portamentos, instruments, and special keys. Those are all sources. And it's saying, and the way I want you to source or to combine those is with a merge. The function that's being called there has one argument, which is the number of sources, and it needs to return a value of a particular type, in this case merge, which also comes from Akka Streams. The eager complete here is true. We do not want to complete this stream if any one of those sources completes. Eager complete would say if, say, the on-offs finished for some reason, then the whole thing would stop. That would basically turn the music maker off. So I'm telling it, don't do that. And then, so that's the input side, right? That's combining all of the input elements into that blue bubble. The output side is just the last line. So we're saying to mat, to the materialization of BroadcastHub.sync. And this is syntactically awkward, but quite powerful. So what BroadcastHub sync does is it gives you that materialized value, which is the source, I believe. Yes, it's the source. So each time you call whatever function this is in, it's going to give you a source. This means you can actually hook up multiple readers of that combined information. Okay? The last set of parentheses where keep.write is, that's a bit of trickery because as you combine things in a stream, you might start collecting different materialized values of different types. Every element of the stream can say, hey, I provide this or I provide that. You might get a whole list of them. This says, just keep the rightmost one. Okay? So that gives us the source that we can read from that is the amalgamation of all of the Music Maker messages. Okay, now we're really going to go for it because this part's a bit tricky. So we want to combine two sources with the graph. What this does is combines the volumes and the pitches together. Remember, the pitches were being generated at a rate of the mouse events were being collected at a rate of 1 every millisecond. And then they were being mapped into the pitch, just an integer for the pitch, so that MIDI knows which pitch to play. But we want to put those into pairs, because to play a note in MIDI needs the pitch and what they call the velocity, or the volume, the velocity that you hit the note with, which translates into the volume. Think of a piano, for example. Okay, so what we're doing here is defining a flow that takes two sources of input, one the pitches and one the volumes, which are coming from the mouse, and outputs basically a play note element. In the first part, I'm declaring a graph stage, and this is how you do specialized stuff. So in Akka Streams, you can use all of those operators that I've been showing you, tick, source.combine. Those are all predefined things in Akka Streams. But here, you're saying, I'm going to create one of those. I'm creating a graph stage using a low-level API that requires inlets and outlets. So we've got an inlet there, which is the pitches port, and a Music Maker messages port, which is the outlet. Okay, it's an outlet that produces play note. It's an inlet of integers. So this is how you get the declarations for the input and the output. Okay, so basically all we have to do is define this create logic function in the graph stage. And in that graph stage, we just do new graph stage logic with the shape. So the shape is a flow, and it's going from integer to play note, as you can see at the bottom of the first chunk there. I'm keeping one piece of value, one piece of data, the last volume. And I'm keeping that by setting a handler for the, I have to remember how this works. Oh, I'm sorry, the volumes.run for each. So volumes is a source that's passed into the constructor. If you look way back up at the top, there's a channel and volumes. Volumes run for each, basically gets a volume value and assigns it to last volume. So whenever volume comes in, it's just keeping the last one. The reason for this is I don't want to generate anything when the volume changes. I only want to generate something when the pitch changes. So I'm creating there's two set handler calls, one for pitches port and one for Music Maker messages port. Pitches port is the input, Music Maker messages port is the output. Therefore, we use new in handler and new out handler. They have specific methods that you must override. In the case of an in handler, you override on push. So this says the value that we want to get from the pitches port is assigned to the variable pitch, or the value pitch. And then I immediately push that onto the Music Maker message port, the output, but I wrap it with play note, channel, pitch, and last volume. So that's where the output gets created in that last line of on push. and I'm pushing that value onto the output port. Then on the music maker message port, the out handler has to define on pull, which just tells us to pull from pitches port. So this is how you set up the feedback, and the flow control essentially is handled for you. So a pull means somebody wants some data downstream. And it's going to call this method, because that's the output, that's where the downstream data comes from. And it's going to ask the pitches port to pull, which is actually going to cause the onPush method to get called. It's a bit complicated, and reading the documentation on this stuff is definitely recommended. Okay, so the main point here is you can make this as fancy as you want. This is incredibly simple. Some of these graph stages are very, very complicated, and you can have things that merge and broadcast things in very, very specific ways. In other words, you can do what you want to do. Okay, there's also a feature in here which is random music generation. Let's go through this one. So I'm creating 3 sources here. I select the instrument to play the random notes on, and just assign that to the variable instrument or value instrument. And then I create a source from a single thing, which is the change instrument message. So I say source.single, music maker message is the type, the element that goes in is the change in instrument element. Then I create a source called notes, which is done with a tick every 10 milliseconds. It's exactly the same as previously. This time I'm going to limit it to 1,000 ticks. Right, so this is going to be 10 seconds long. This is 1 every 100th of a second times 1,000 is 10 seconds long. And then I'm going to change that unit value into a play note. So I get the note through a random number generation, and I get the velocity through a random number generation, and I create the play note. And that's what that source is. It's a source of play note, generated every 10 milliseconds. Then there's stop channel, which is a message we need to stop the last note from playing. So we do source.single and provide it a single message, which is stop last note. Then we saw previously combine. We're using it again here to combine set instrument, notes, and stop channel into one thing. But this time, instead of merging, we're concatenating, which just says do set instrument first, do note second, do stop channel. Merge means do whatever has data on it. And so it's going to look at it would look at all 3 if this was merge and just do them in any order that they come in. This says no, run set instrument all the way to completion. It's only one message anyways. Then run all the notes, run that to completion, then run the stop last note. That's concatenation. Okay, so I'm going to demonstrate a few more features. I had hoped to be able to show this to you. I'm going to try that one more time. It disappeared on me again. That's really amazing. Okay. You see that little gray bar there? That's my window. Oh, look. Amazing. No, this is not easy to do. I wonder if I can just get that to go. And it still works. Okay. So you can see the notes changing. You can see the instrument change here. Note that it doesn't play anything until I move the mouse. Should be getting louder and softer. Okay, so we can do lots of things here. There's also keyboard events. There's a few other things, and I'm not going to show the slides for them because it just says do the demonstration, so I'm going to show them to you. Hopefully me switching windows here isn't going to be too horrible. Okay. Yeah, it does it while the window's not that's a feature of Sling, apparently. You don't have focus, but you can get the mouse position anyway. Let me see here. How do I get back to my browser? Oh, because it doesn't have a window. That's why. Let me not drive you crazy with that. Okay, so interesting. Yeah. Good luck with that on a keyboard. I had some of these comments when I did my proof of concept to my internal team. Now, come on. This is Grafana. In addition to doing all of the music making component, there's also a metrics collector for in Grafana. And unfortunately, it seems to have disconnected since I had this running before. So it's less than overwhelming right now. I had hoped that while I was playing, it was actually collecting all these metrics, but something has gone wrong. I can show you, however, that it isn't totally fake. This here is the metrics page from the program. And if you know anything about Prometheus, this is how it's being collected. So this is, my program is generating this page of output to get all the metrics. And so you can see that anything that starts with MMAS or MMWAS is music making with Akka Streams. That's application metrics. Where am I on time? 5:05. Okay, got a little bit of time. So I'm going to switch back to presentation, if I can. So I didn't quite demonstrate all the features. Okay, so there's some others, like this one. This is, note that there's also a display of which keys are being pressed. So I type Control-1. Oh, and turn the volume up. Row your boat. There's also a random music function, which I showed you, which this is annoying, but I'm going to play it for you. As soon as this is done. So this is the consequence of doing combine, concat. So this is one concat. I type Control-R, but it hasn't been processed yet because this one's not finished. And no, it's not done yet. Okay, now it's done. have the window having input. Well, maybe it just doesn't work. Oh, it's just too quiet to hear, that's all. Well, that's interesting. The random number generator here is sort of giving us a repeating pattern. Huh. That's new too. All right. I'm not sure what's going on there. So what I did with the metrics is just added another consumer of the Music Maker message MergeHub. Remember, that was that complicated thing that had all the inputs and outputs. I've summarized all the inputs just with one thing there. But there were 7 or 8 of them. And in addition to updating the screen and creating the music, I just got something that creates a /metrics page, and I did that with Akka HTTP. So how is that done? So this is about diverting the metrics to the metrics server. So I took in some samples, that would be the notes that are being played, and I did it through this thing called Terminus, which I'll show you in a second. And then I filtered out any of the not used messages. Actually, I filtered anything that is, I'm trying to remember how this works. Hang on a second. Oh, this is to produce the output. So I'm basically just counting how many messages they are. Messages is a metric in Prometheus that's counting the number of messages. And so when I get to the 1,000th or 2,000th or 3,000th, in other words, if the modulus of this is 0, then it puts out the message. So then every time I get a message, and we don't really care, that's what the underscore means, I print out the values of the counters, messages and notes. Not all the messages are notes. Most of them are, but not all of them. And you can see that in the output. If I can get this window over. So I'm running this from IntelliJ. You can see down there at the bottom that output is coming out every 1,000th time. All right, let me put this back. So that's basically how the messages got captured, but the main work is in Terminus. So here's how you make a flow from a function. You just say flow from function, and you pass in a function. So we have the music make messages going in, and a big case statement. Thank you for that. And so I'm just matching on the message, and for different kinds of messages, I'm incrementing counters and doing things. The interesting stuff happens on play note, where I increment the number of messages, I increment the number of notes, I set the pitch value to a double value from pitch, I observe a new value for velocities. You do observe for histograms. And same thing for channels. Then I get the time of that, and I do a different kind of timed observation for durations. How long did this thing, how long did the notes take between notes? And other things. There's other messages, but I didn't include them all on the slide. So this is a way of processing things in the middle of a stream. Okay. So the next thing is that all of this actually runs on a Raspberry Pi, too. Assuming I can get that to happen. So bear with me. I'm going to change the screen to my Raspberry Pi. That's it. You can do Akka Streams on a Raspberry Pi. It will play music, And you can do it all with a whole bunch of fancy streams all connected in. Thank you. I'm happy to take a few minutes of a few questions. Let me get rid of this. Actually, could you lower that for me a little bit? Thank you. Happy to take questions until they kick us out. There is another speaker right after this. So I think we've got 15 minutes or so. Yeah. You need to come to the microphone because this is being recorded, so we want to be able to have all the listeners hear the question as well. So if you got a question, come to the microphone, please. And that'll stop in a second.
Thanks, great talk. Have you run into any problems with garbage collection pauses causing glitches in the music?
Yes. If you were listening carefully, you probably heard a few. One, especially on the Raspberry Pi, where the G1 GC is not available. For whatever reason, Oracle 8 didn't provide that on the, I guess, on the AMD platform. G1 GC allows you to minimize the amount of time, but you know, if you're really trying to do high fidelity, it's probably not going to work.
Thanks.
Yeah. Anyone else? If you have questions, just come and queue up. We'll get through them faster that way.
I took the Akka Streams work class, so I just have a small question. Is the only difference between VIA and Combine just the number of sources that you have?
Yes. So VIA takes one flow, whereas Combine is for combining sources. Yeah. Anyone else? All right, you're free to go or can stay and ask more questions. Thank you.